Let's have a quick recap of previous lecture. We saw role of lexical analyzer. We studied different terms such as tokens, patterns, and lexeme, and we also saw some examples of tokens. Let's study the next concept called as input buffering. Lexical analyzer scans the input string from left to right, one character at a time. To ensure that a right lexeme is found, one or more characters have to be looked up beyond the next lexeme. For instance, we cannot be sure if we have seen the end of an identifier until we see a character that is not a letter or digit and therefore is not a part of the lexeme for ID. In C, single character operators like equal to or less than could also be the beginning of two character operators like equal to or less than or equal to. So we need to look ahead one or more symbols in order to identify a valid token. Okay, so we have some techniques here called as input buffering techniques. There are two types of techniques. There is one buffer technique and two buffer technique. So let's see how these techniques work. Before actually proceeding with one buffer and two buffer techniques, I'll explain you all how this buffering technique works. So just assume that you have some input in this buffer as initially, the initial configuration of this buffer is there are two pointers which point to the start symbol. So there is something called as BPTR and FPTR. Okay, so there are two pointers which are maintained. BPTR remains at the beginning of string to be read and FPTR moves ahead to search for end of lexeme. Now, this FPTR moves forward one character at a time. So when this FPTR moves forward, it encounters N. Again, it encounters T. Once FPTR encounters this blank symbol here, okay, it means that whatever is there before this pointer is a part of lexeme, is one lexeme. Okay, so INT is considered as one lexeme. So once this lexeme is found out, both FPTR and BPTR will point to the next character after this blank symbol. So BPTR and FPTR will point here in order to find the next lexeme. Fine. Now, in case, as I already mentioned, that there are two buffering techniques, that is one buffer technique and two buffer technique. In case of one buffer technique, only one buffer is used in order to store the string. Now, the problem over here is if the lexeme is very long, it crosses the buffer boundary. To scan the rest of the lexeme, okay, the same buffer has to be refilled again. Okay, so that is a disadvantage. So we introduce one more technique called as two buffer techniques, wherein two buffers are used in order to store the string. First buffer and second buffer are scanned alternatively. When end of current buffer is reached, the other buffer is filled. Problem again over here is if the length of lexeme is longer than the length of buffer, then the input cannot be scanned completely. There is one special character which is used to mark the end of buffer. Okay, that is EOF. Okay, so a special value is stored called as EOF in order to mark the end of string. So that is a difference between one buffer technique and two buffer technique. The next very important concept in case of lexical analysis is regular expressions. Regular expressions are very useful for representing the set of strings belonging to some specific language. You must have already studied some notations in your ALC course. Say, for example, plus is for one or more occurrences, star is for zero or more occurrences. If I write A to Z, means that it is a range. If I write 0, 1, 2 inside this bracket, it means I can recognize 0 or 1 or 2. Yes, so the regular expressions play a very important role in case of lexical analysis. In order to identify the correct lexeme, that is to identify correct tokens, we write some set of regular expressions, and these regular expressions are written in a program called as lex program, which is lexical analyzer generator. One simple example of a regular expression for identifier can be, so I can write rule for identifier as identifier should always start with letter, or I can have letter or digit star. Okay, so this is one pattern. This is a regular expression. What about regular expression for this letter? This letter is a word, right? So what I'll do is I'll write regular expression for letter as say A to Z or capital A to Z. For digit, I will write regular expression as 0 to 9. Okay, so I define a rule for identifier as identifier name should always start with letter. So that corresponds to this. Okay, so I rename this regular expression as letter. I rename this regular expression as digit, and I form a new regular expression by using combination of these two. So letter, and after that I can have either letter or digit star, that is 0 or more occurrences of this. Fine. So if I want to check the correct token, say for example correct identifier, say if I give you all one example as A, checking whether A is a valid identifier or not. According to this regular expression, yes, it is a proper identifier. Why? Because A corresponds to this letter. After that I can have 0 or more letters or digits. Okay, so in order to represent this regular expression in the form of automata, okay, so automata comes into picture here. So automata consists of set of states. There is initial state, there is final state, and there are some transition symbols, right? Okay, so in this case I'm representing this regular expression in the form of this transition diagram. So I have the state numbers as 9, 10 and 11. I represent a regular expression in the form of this transition diagram, that is letter. So I represent it here. After that I can have either letter or digit. Okay, so if it is letter or digit, if it matches, then it goes to the final state. Okay, and if it is an identifier, this return get token function and install ID corresponds to storing information about that identifier in symbol table. Now coming to the actual lexical analyzer generator, as I had already mentioned, input buffering, regular expressions and finite automata forms the basis for this lex tool. Okay, now let's understand how this lex tool actually works in order to recognize the correct set of tokens. Okay, a lexical analyzer is a program that transforms an input stream into a sequence of tokens. It reads the input stream and produces a source code as output through implementing the lexical analyzer in C program. So how this lex tool works? Okay, we'll see the detailed working of this lex tools along with some examples. Firstly, the lexical analyzer creates a program called as lex.l file. Okay, now so there is a lex compiler which is Unix utility. You can install it on Ubuntu platform. So we write a program named as lex.l. Okay, any program name with .l extension. Now this program, we'll see the structure of lex program in the next slide. We give this lex program to lex compiler. Okay, now this lexical compiler will give output in the form of .c file. So when you give .l file to lexical compiler, it will generate lex.yy.c. By default, anytime if you give .l file to lexical compiler, it will be lex.yy.c file. Fine. Now this is a C program. Okay, this is a C program here. So can I give this C program to a C compiler in order to generate output? Yes. So the next step is this .c file is given to a C compiler and we obtain a.out file. Once you get this a.out file, You give your input stream here, you give input to this, and the output is you get the sequence of tokens, which is the output of lexical analysis. The structure of Lex program, okay? Lex program is same as C program with slight changes. Okay, so there are three sections in case of Lex program. We have declarations, then we have translation rules and auxiliary functions. I'll give you all one simple example of Lex program which is used to count the words, number of words. Okay, so the first part is a definition section which is enclosed inside this percent opening bracket and it closes with percent closing bracket. So if you want to include any header files which will be required in your program, say for example stdio.h, string.h, if you want to specify some initializations, all those statements are to be written inside these two symbols. Okay, so that is first part. The next part is rules section wherein the regular expressions comes into picture. Okay, so here the regular expressions are defined as some regular expression along with some action. Okay, so you write regular expression here and the action part will come inside this curly braces. Fine. So there is one more rule here, that is \n. So this is a regular expression for recognizing new line character, and the action associated, if I encounter this /n, if I encounter a new line character, what is the action which is to be performed? So that is printf %d, I. Now I is equal to 0, some action, some statements. Fine. There are some other functions in case of Lex program which we are going to see in next lecture. There is main function in case of C. There is one very important function that is a starting point of Lex program that is called as yylex function. Okay, it's a starting point in order to call the Lex program. Steps to execute a Lex program. The first command is lex program name.l. The output of this will be .c file, that is lex.yy.c. So you give command as cc lex.yy.c, press enter and then execute this a.out file which is used in order to get the tokens as ./a.out. Once you press enter after this command, it will wait for user to type the input. Now when the input is taken, it will follow certain steps in order to recognize the tokens. The detailed procedure, okay, how it works, I'll explain you all in the next lecture. Till then, happy learning.